Welcome to The Explainer. We're all about breaking down big topics in just a few minutes. And today, we're going to tackle the secret language of numbers. You know, number bases.
All right, so let's just jump right in with a question. Imagine you see the number 101 written down. What does that really mean? Now, you're probably thinking it's 101, duh. But what if I told you it's not always that simple?
See, for us humans, yeah, it's 101. But for a computer, that same 101 could actually mean the number 5. How is that possible? Well, it all comes down to the language the number is written in.
So to really get how this works, we've got to start with what we know. Let's break down the system we use every single day, most of the time without even thinking twice about it. Base 10.
So why do we call it base 10? It's actually super simple. It's because the whole system is built around the number 10. We've got 10 digits, right? 0 through 9. And every single spot a digit sits in, that spot represents a power of 10.
Okay, let's take a number like 345. It's not just the 3, a 4, and a 5 hanging out together. Each one has a job to do based on its position. The 5 is in the ones place. That's 10 to the power of 0. The 4 is in the tens place, and the 3 is in the hundreds place. You add up what each of those positions is worth, and voila, you get 345.
Okay, so once you really get that idea, that the position is just a power of the base, you basically unlocked the secret to any number system. Seriously, that's the universal key right there.
So what is a number base, really? Think of it like a simple set of rules for a game. It just tells you two things. 1, which digits you can play with, and 2, how much each spot on the board is worth. And here's the most important part, the real takeaway. The same exact logic we use for our normal base 10, it works for everything. If you're working in base 5, each position is a power of 5. In base 2, you guessed it, each position is a power of 2. The fundamental idea never, ever changes. For example, let's look at base 2, which you've probably heard of as binary. Take the number 1011. Now that is not 1011. In binary, it means you have 1 8, that's 2 cubed, 0 4s, 1 2, and 1 1. You add all that up, and it's the number 11 in our everyday base 10. All right, so now that we get the basic structure, we can start doing some really cool stuff, like translating between these different languages for numbers.
So let's say we want to write the number 45 in a way a computer can understand. We've got to convert it to base 2. And the method is actually pretty simple. All you do is keep dividing by 2, over and over again. And the key thing is to keep track of the remainder each time you divide, all the way down until you get to 0.
And now for the big reveal. You take all those remainders you wrote down, and you just read them from the bottom up. And just like that, you've got it. 45 in our world is 101101 in the computer's world of base 2.
And guess what? Going the other way is just as easy. If we have a number like 213 in base 5 and want to know what it is in base 10, we just do what we did earlier. We expand it out. So that's 2 25s, 1 5, and 3 1s. Add it all together, and you get 58. Symbol.
Okay, but here's where it gets really interesting. You can do normal math, adding, subtracting, all of it, in any base. The only catch is you have to play by that base's rules. Let's try one out. We're going to add 3, 4, and 2, 2 in base 5. And it's super important to remember that's not 34 plus 22. We're in a different world now, the world of base 5. So, just like we always do, we start with the rightmost column. 4 plus 2, that's 6. Uh-oh, problem. In base 5, the digits only go up to 4. The number 6 doesn't even exist here. So now what? Well, the solution is something you already know how to do. It's just like carrying the 1 in regular addition, but instead of carrying a group of 10, we carry a group of 5, because we're in base 5. So 6 is one group of 5 with 1 left over. You write down the leftover 1 and carry that group of 5 over to the next column. Okay, on to the next column. We have 3 plus 2 plus that 1 we just carried. Hey, that's 6 again. So we do the same thing, write down the one that's left over, and carry the other one. And since that's the last column, that final carried one just drops down. So our answer is 1, 1, 1 in base 5. So, after all that math, what's the big takeaway here?
What's the point of all this?
It really just boils down to this. Different number bases are just different ways of writing the exact same amount of stuff. Whether it's 58 or 111 in base 5 or 101101 in base 2, the actual quantity, the value, it hasn't changed at all. All that changed is the language we're using to describe it.
So, if this helped you look at numbers in a totally new light, do us a favor and hit that like button. And of course, subscribe for more explainers where we break down big ideas just like this. Thanks for hanging out with us.